Oops, I forgot to balance it with the new battery position.
Mode change to Alt hold. Mode change to loiter.
Let's try to keep it as low as possible for this test. I don't see any extra vibration on the GPS mast.
Mode change to Alt hold.
GPS was working in loiter, but let's keep it in as simple mode as possible.
Mode change to stabilize.
All the way down to stabilized mode so that if I have a GPS glitch it will not make it do anything. We'll just keep it at this and see what happens.
Mode change to Alt hold. Mode change to stabilize.
20-second warning to the 10-minute mark. Ten-second warning to the 10-minute mark. Ten minutes. Get it back up through alt hold into loiter for auto landing.
Mode change to alt hold. Mode change to loiter.
Nudge it around for where I want to land it.
Mode change to land.
Perfect.
Mode change to stabilize.
Now let's see what kind of data we developed. Okay, let's dig out the data we need. Let's look at IMU data. I only have one on here. Packages are capable now of dual sensors for all sensors. There we have the X, Y, and Z of the accelerometers. And X and Y acceptable ranges are plus or minus 3. This would be 5. I am well within plus or minus 3, so vibration on accelerometers X and Y is extremely low actually, and definitely less than 3. And on the Z axis, the acceptable range is minus 5 to minus 15. Here's minus 5. Here's minus 15. We do have some what I would consider glitch values outside of it, but in general vibration is well within acceptable limits there. Let's see, next we would want to go in and look at during the hovering period the throttle output value. Here we go. And while I was hovering, which is most of the time, except for that one little jump up in the air, we'll look here. We're right at 360-ish or so. So let's go see what that parameter is set at. Okay, near the top of the text log is the values, every value set, and here's our throttle mid for that, and it's set to 300. So it was hovering with a throttle value of about 360. When it comes out of that mode, it's actually going to drop it to 300, which means the craft is going to descend, but not radically, which is really what I want. I don't want it to go zooming up in the air when I move from a mode that uses the barometer for altitude hold. If you if this was set at the default 500, it would really go zooming straight up in the air anytime you would come out of a barometer controlled altitude, which if you aren't careful with a powerful platform like this, it gets away from you. Kind of a lot to this. So I think this test overall is good. We didn't develop any. I will come and look through. This log has, oh, I hate to go through this with everybody right now, but basically after some values are saved of what the program parameters are, then it tells you every parameter. Looks like 3.2 is sorted by group rather than alphabetically. So, and then after that, we actually have right here that I am running version 3.2. I'm running a hexaframe. I'm going into stabilize mode. Here you see, and my throttle is at 397 at that instant. And then I will not get into what all the rest of these values mean, because they are in actuality the moment by moment values for GPS, throttle position, what the barometer sees, what the mode is, what the IMU data is. I do not have a second IMU on it, which is the accelerometers. I do not have a second GPS on it. This will repeat over and over and over and over. And let's see if we stick this in Word real quick, just to illustrate why I'm not going to go through each and every value and what it is representing. In this file we have taking a second to load here. We have it's still counting, calculating down here in the left hand corner, because we're currently at 270 pages worth of telemetry data that was saved away. Maybe I shouldn't. There we go. We start counting up. 700 pages, 800 pages, 900, 1,000 pages. Let's assume, well, no. Still loading it. And this is an extremely fast computer. I do have the value for how much telemetry data saved set to an extremely high level, because I am looking for possibilities of problems. I will change that back down after I'm sure of this platform again. It's called the log bit mask, log_bit mask parameter, and basically you can see here, large page, there are 83,472 lines, each one representing a momentary, oh sorry, it got finished. There are 234,269 lines of data in this file, each line representing a momentary item of data for whatever perimeter it is representing and the corresponding values, so I can look at them. So I'm not going to go through 234,000 lines of code with you guys line by line and explain what each one of them means moment to moment. We were just going to look at that top part. I can certainly go and tell you that anytime you see IMU2 in here, the corresponding values after it don't mean diddly, because they are not. Let me stick this back in text mode real quick, make it appear better. There's some word wrapping going on there. 234,000 lines of text. We'll page down through them here, just give you a quick glance. I do have one accelerometer in there, so these values would be the values instantaneously at that moment based on this value. For that accelerometer, I do not have a second accelerometer. Here's a magnetic compass reading offsets. I do not have a second compass. You can put a second compass on these now. On these platforms you can have 2 accelerometers, 2 GPSs, 2 compasses. We will get to quad redundancy hopefully soon, and then these things can fly all over the place and you won't have a problem. Here's a GPS reading and the corresponding GPS coordinates. There's also speed, acceleration based on the GPS in there too. It would just be too much for too many little brains to go through this, even on a simple one, line by line. But this is the telemetry data out. And again, if we go back up to the top, let me do that real quick. You can search for, get to the top, log underscore bit mask. Whoops. Yes, you can't find it if you can't spell it correctly. Just wash my hands. Can't do a thing with it. Ah. We'll just search quickly. LOG underscore. There we go. Log underscore bit mask is set to 4306. I know that probably seems cryptic to you too when you understand all this software and stuff fully, which most people will never need to understand. It's people like me and the makers of these autopilots and stuff that really will be doing most of this for you. I don't mind helping any of you, but this corresponds in the setup to a value that says I want to save almost everything. Alright, so that pretty much does it for this test. Next, knowing that this platform is pretty much functioning properly now, we'll have to go to a field where I can actually stress it a little bit with some climb values, heavy climb acceleration, kind of throw it around the field on the other axes, whatever, and hopefully never generate another GPS glitch. I will tell you at this point, a GPS glitch when in loiter mode, of course, will make the GPS think it's someplace else in the world, and in order to keep it where it was based on the last GPS value, it needs to go someplace else, which these platforms will do at a very radical and very accelerated rate. There is a perimeter to control how fast it will do that. I won't get into that, but my point is all of a sudden your platform that is loitering in one place in time and space can suddenly think it needs to go about 10 miles away, and if your parameters are set really high, it will try to do so at max performance, which to you looks like it was sitting there and suddenly it took off in a random direction. The way to handle that type of problem, if it crops up, is to go into stabilize mode. Fall to your lowest possible mode. Therefore, in stabilized mode, the GPS is no longer controlling the platform. The barometer is also no longer controlling the platform. You are in your most basic mode, and your inputs from the control sticks are what is going to happen. So I generally, if I'm flying in stabilized mode, I have thumb on throttle and thumb on the pitch yaw control stick, and I'm ready for any kind of hiccup out of an ESC or a motor doing something funky, which the only thing you can do there is try to offset it. If, let's say, a right motor goes out, you're going to go down. You might as well chop the throttle, try to save everything as much as possible. You can, if you're quick enough and experienced enough, when you get near the ground, try to put it into a position with the roll that's going to cause the platform to try to level itself up the throttle just before the ground to try to level it out. That's an instinct thing. I cannot teach you at all. There is a autopilot that will do all this automatically for you if you lose one motor, perhaps two motors. That's the what is that? That's the DJI NASA with the $1,500 upgrade to it that I can't remember right now. I don't use that. I'm using 3DR's platform. They win the Outback Challenge every year, so I kind of like them. But basically, you have to be prepared for extremes. So generally, if I'm flying in modes above stabilized, say altitude hold, loiter, drift, acro, or any of the other 15 possible modes, technically, because I don't really need the throttle, I've actually got my thumb on the switch ready to move it into stabilized mode as soon as I see something, some strange movement out of the craft that I'm not expecting. I will immediately flip it into stabilized mode, and then get my thumb back on the throttle to try to compensate for whatever's going on. Let's say if you're flying along in drift mode and suddenly it seems to go flying off in a direction you didn't expect, if everything goes well, you can flip it into stabilized mode and go to mid throttle and center the right joystick. And if your ESCs and motors are all in good shape, you should basically come to a stop right there in midair without either going right, left, up, down, forward, or backwards. That's what you're trying to do. You're trying to get it back under control. These things come with experience. Also, you'll find that if you do not do these tunings so that a mid-throttle is adjusted for the power of the platform, you're going to be searching all over that throttle control stick trying to find a way to keep it from going up and down. All these things must be set up properly before you fly. You have to really understand a few complex things with these autopiloted UAS platforms. If you kind of work into it, you'll find it's not too bad. Like I say, I've got probably close to 200 hours now in air. I've seen so many problems. At first, I didn't do too well handling them. What you'll find as you go on, get more experience, they become more and more easy to handle. I would say in the last year, going on 2 years, I probably have, oh Lord, 2,000 or 3,000 hours of bench time studying the programming and the hardware functions of these autopilots. So I'll be glad to help you with 3DR autopilots 2.6s or Pixhawks anytime you like. Just contact me here. I will do everything I can for you. Alright, not sure what else I can tell you except have a good one. Keep the blue side up.